Hello, welcome everyone. We are in our Unit 4 classwork packet. All right, topics A through C, lessons 1 through 8. We're focusing in on lessons 3 and 5 today. Don't worry, I know where 4 is at. It's all under control. Okay, so the big thing that we are after here is we're talking exponents. So repeat multiplication. So what they bring in here is, hey, there's repeat multiplication and there's repeat addition. So repeat addition is multiplication. Repeat multiplication are exponents. All right, so that's what we're gonna be walking through here today. So in the problem setup here, we're gonna do a few together and we'll let you take care of some of them. I'm noticing here that I've got some repeat addition going on in question number 1. So because it's repeat addition, it's going to be a multiplication problem. So because I see 10 plus 10 plus 10, that would be the same as taking 10 and multiplying it by 3. Remember, we do like our parentheses for multiplication. We like our dot for multiplication. Stay away from that X. All right. Let's go down to question number 4. Okay. Now I see a multiplication problem. So in these directions, remember, if it's an addition problem, they want me to rewrite as multiplication. If it's a multiplication problem, they want me to rewrite it using addition. We're not going to see any exponents here because there's no repeat multiplication. 3 times 9, those people are different. So 3 times 9, there's 2 ways that I could do this problem. There's the long way that I could do it, or there's the faster way that I could do it. So what I could do is, because we're taking that 3, and this would be the long version, I'm going to repeat addition 9 times. Like I said, I told you it's going to be the long way that's there. Let's see here. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Woo! All right. That's good. Or what I could think of is I could think of that 9 times the 3. And so it could be a 9 plus a 9 plus a 9. Again, just doing the opposite there. Either one's fine. All right. As you can see, that 9 plus 9 plus 9 is a lot nice looking. Okay, and then there's one that we're going to do down here is question 6 together. I see repeat addition, which means it's a multiplication problem. So we're going to how many D's are there? 1, 2, 3, 4, 5. Okay, so that means 5 times D. Remember, when you multiply a number and a letter right up against each other, all right? No dots. We could get away with it. It's just not good math grammar that's there, all right? Number first, letter second. Go ahead, make sure you're filling in the in between. So if you want to pause the video right here and finish those guys and then keep on with me, hey, that's fine. That's fine there. In the next section, they're asking you to fill them in. So let's see here. Let's take care of, I'm going to work through this one, this exponential form, this 9 to the second power. Remember, exponents, little numbers pushed up in the air, repeat multiplication. So 9 to the second power is really 9 times 9. All right, repeat multiplication. That 9 is the base, so that tells me the number I'm going to use. The exponent tells me how many times we're going to multiply that 9 together. So because it's 2, hey, that's why I got 2 of them. So standard form just means the answer. All right, normal numbers, if you may. So 9 times 9 is 81. We're going to do the fraction one here together. All right. I see again 1/2 to the 5th power, which means it's a half times a half times a half times a half times 1/2. Woo! All right. 1/2 to the 5th power. Again, repeat multiplication. I'm going to use that 1/2. I got to write it down 5 times because the exponent's a 5. So to multiply fractions, let's not get scared here, people. We just multiply straight across. All right. 1 times 1 times 1 times 1 times 1. Yeah, just 1. All right. And then down below here, it's 2 times 2 times 2. Okay, so let's see here. 2 times 2, 4. All right. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. Yeah, so it's 1/32. Again, You can fill in the other two that are there. Pause it if you want to, so you can kind of keep up with what's going on here. All right. Question 8, we're going to talk through here together. It's not one that I expect you to be aware of, but we do want to make sure that we can kind of see it because it did happen up here. And in the table, we had a whole number, which is a 9, and then we had a fraction for a half. So they want to know is why do whole numbers raised to an exponent get greater? Okay, 9 became an 81, while the 1/2, ooh, actually got smaller, 1/32. That's smaller, that's there. Okay, and so here's what we're looking at. So why do the whole numbers raised get greater while fractions get smaller? All right, so the idea behind the fractions is multiplying by a fraction is really division in disguise. All right, let's think about it here. Let's think about it. If you are taking something and you are going to, let's say you're going to take 4, all right, and divide it by 1/2. What we actually do, make our 4 into a fraction. Remember, to divide, we multiply by the reciprocal. All right. So these are the exact same statements. So if you're dividing something by a half, all right, you're really multiplying by 2, so you're going to get 8. So that's why that one's getting bigger with the division with the fraction. But we're not dividing with the fraction. We're multiplying with a fraction. All right. So if we're doing 4, all right, times 1/2, all right, remember what's really going on here is it's a division problem. So I'm going to take it the other direction here. So that's really 4, all right, and then divided by, and then 2. So dividing, all right, is really the same as multiplying by a fraction. And that's what we're getting after here. Division, all right, is multiplying by a fraction. Again, not as obvious. I get it. I get it there. But it's something we do want you to be aware of that, hey, your fractions, use a fraction, it will get smaller. That is completely normal there. All right, let's look at question number 9 here. Number 9, they're asking for find the powers of 2. Okay, so powers, those are your exponents. They're in the range from 2 through 1,000. Okay, and so they're telling you what they are. Find all the powers of 3 that are in the range. Okay, so what they've got going on here is what they're saying is 2 to the first power, all right? Man, that is not writing out very well. There we go. A little bit better. Is 2, all right? There it is. 2 to the second power, 2 times 2, all right? That's my 4. So there it is. 2 to the third power, 2 times 2 times 2. Well, 2 times 2 is 4, 4 times 2 is 8. And there's that. So that's what they're getting. So what they want us to do, though, is they want us to list all the powers of 3. But they're saying, hey, hit the brakes once you get to 1,000. So 3 to the first power, 3. All right, just the 1 3 that's there. 3 to the second power. Well, that's 3 times 3. So that's 9. 3 to the third power. 3 times 3. Are you with me here? All right. 3 times 3 is 9. 9 times 3, 27. Remember, they're saying, hey, once you hit 1,000, we can stop. Now, you might be thinking this is going to take forever, but oh my goodness here, people, we're multiplying. Watch what's happening here. Right? 3 to the fourth power. 3 times 3 times 3 times 3. All right. So 3 times 3 is 9. 9 times 3 is 27. We got that there. 27 times 3. Yeah, mental math. All right. It's 81. Now, you might be like, whoa, where'd you get that? Well, hey, check it out. Here's our properties. 3 times 3 is 9. 3 times 3 is 9. 9 times 9, hello, 81. All right. 3 to the fifth power. All right. Well, if you've probably noticed by now is I've already got 3 to the fourth power, which I know is 81. But now I just got to multiply it by another 3. So I'm going to do an 81 times a 3. So 1 times 3, 3. 8 times 3, 2. Oh, now I'm at 243. All right. Let's see here. 3 to the sixth power. All right. Again, I've already done 3 to the fifth power. I've already done. I'm adding on. I should say I'm adding on. All right. I'm going to multiply by 1 more 3. And so I'm going to take the previous one and multiply by 3 because that's already got all the other 3's that are in there. So 3 times 3, I'm going to have to multiply. 3 times 3 is 9. 3 times 4 is 12. Carry the 1, 729. Now, here's the thing is I'm hitting the brakes right here. Why? Remember, we want to get to 1,000. All right, using my estimation, if I do 729 and times it by 3, that's going to be way over 1,000. So find all the powers that are in. So I've got them all. All right, I've got my 3, 9, 27, 81, and my 729. All right. In question number 10, they're asking you to do it with your force. So again, you're 4 to the first power, get your answer. 4 to the second power, get your answer. 4 to the third power, get your answer. Remember, it's repeat multiplication. I've had students in the past that are like, Mr. Savage, I've been doing 4 plus 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 4. No. Repeat multiplication. Your people are doing our powers that are there. In question 11, write an equivalent expression for 5n using only addition. So remember, a multiplication problem is addition. So how many n's are there? 5 of them there, right? Yeah. So there's your repeat multiplication that you're doing there. So question 12, write an equivalent expression for w to the fourth power using only multiplication. So I'm gonna let you write that one out there. What we're gonna talk about here is the parts. Explain what w is in this new expression. We call this guy the base. Okay, that's the formal word. Again, you'll start using it over time. It'll become more familiar to you, but it's for that bottom number or what you're using to rewrite it with. That's called your base. Explain what the 4 is in this new expression. That's considered our exponent. All right. We can call it exponent. We can call it a power. You could tell me it's how many times that you're going to be multiplying something together. All those things are going to work. And then what are the advantages there? All right. What are the advantages to using exponential notation? All right. Well, simply, it's a faster way to write. Instead of writing out 3 times 3 times 3 times 3 times 3 times 3, again, we can write it out as 3 to the 4th power, or in whatever case. All right. Okay, so I'm gonna let you take care of the last one here. All right. You're gonna do 4x. All right, and you're gonna use x equals 2. And then you're gonna do x to the 4th power. And again, you're gonna use an x equals 2. You should find you're getting different answers here. Remember, because this is a multiplication problem, and this is a repeat multiplication problem. Did I just give the answer away? I think I might have. You might have to rewind. All right, guys, we'll see you later.